Hello everyone. In this lecture I will go over moment of a force, and we're going to discuss how to express and how to find it in scalar notation and scalar format. First, let's look at general application of a moment. So in a minute I'm going to discuss what is a moment, but if you look around you, we are using moment on a daily basis in a variety of applications. Anytime you use a tool, that most probably you're using a moment. Driving, opening a jar, again using a wrench, pulling out a nail, all of that are examples of using a moment. And in general, moment is creating a tendency for rotation. So anywhere that you're applying a force which is going to create some sort of a rotation or tendency for rotation, you are using moment, and you're applying a moment. So let's see. So moment of a force. When force is applied to a body, it will produce a tendency to rotate the body around a point, and this is important, that is not on the line of action of the force. This tendency is called moment. That is not on the line of action of the force around the point. So using a ratchet wrench, applying a force to loosen or tighten a bolt, you're applying a force to that wrench. That force is creating a tendency for rotation or a rotation about point O. And as you can see, line of action of F is this line, and the point O is not on the line of action. Look at this one. You are using the wrench wrong, obviously. You're just pulling on it. This is line of action of F. Point O is on line of action of F. No moment. If you start pulling on a wrench, you're not opening or tightening or loosening a bolt. But here, O is not on line of action of F. Therefore, you are creating a tendency for rotation. And in a minute, we're going to talk about this distance D that I've marked here. But any way that you apply this force, as long as that O is not on the line of action, this moment is created. The blue arrow, O is not on line of action of F. Okay. Moment of a force is a vector. And as you know, vector has what? It has a magnitude and it has a direction. So I have two figures here. One is kind of more of a 3D, one is just looking at it flat. So I brought these two so you can understand it doesn't matter, 2D, 3D. The principle of moment and concept of moment is applied the same way. In both of these cases, the point O is not located on the line of action of that force that is applied. So if moment is a vector, it has a magnitude and it has a direction. So let's look at it, magnitude of it. So the magnitude of moment about point O equals F d. F is magnitude of force. D is what we call the moment arm. Moment arm is perpendicular distance between point O and line of action of F. And this perpendicular is really important. That D needs to be perpendicular distance. So right here, this is the line of action of F. Again, it doesn't matter which point F is applied. All we care about is line of action of F, not which point it is applied and point of application. Point O, the perpendicular distance, you can see in this, the figure, let's call it figure 1, and it is distance D. Point A is the application point of force F. This is the line of action. Therefore, the distance D is where you find the distance between point O and perpendicular distance between point O and line of action of force. So this was the magnitude. Magnitude, check. Let's look at the direction of it. Direction of it, let me call this 1, magnitude, 2, direction. Direction is defined by moment axis. And here I want to emphasize the rotation is not direction of moment. Okay. This axis perpendicular to that plane that you see, the arrow is the moment axis and direction of moment. And direction is defined by right hand rule. So the fingers are curled toward palm in the direction of tendency of rotation. The way that fingers are curled, this is the rotation, and your thumb is pointing to your moment axis. Same here, vector M point this direction of the thumb. So again, a kind of a flatter image, a 2D, and also a 3D body that force is applied. So let's kind of review here. Moment of a force is a vector. The magnitude of it is M. Magnitude of M is force multiplied by distance, and the direction of it is dictated by right hand rule. Sorry about that. I was looking through my notes there. So moment axis, as I mentioned, is perpendicular to the plane that contains what? Force F and moment arm D. So these two, they form a plane. It's kind of better visible in this image right here. And the moment axis is always perpendicular to that plane. So same as forces, that we had resultant forces, we can find resultant moment. So if all forces on the same plane, that like here, are on xy plane, the resultant moment is just the algebraic sum of each moment. And usually, if the rotation, again, rotation is different than direction of moment. If the rotation is clockwise, this is just a convention, an agreement. We usually take the moment to be negative. If the rotation is counterclockwise, then we take it as plus and we just add them together. So resultant moment about point O is summation of all FD. Remember, this D is perpendicular distance between O and line of action of F. For example, in this figure here, we have F1 D1, and that is creating a counterclockwise. We usually like to put a little sign here and says, hey, just to kind of remind ourselves, if it's going counterclockwise, I'm going to take it positive. So in this figure, F1 D1 is going counterclockwise, so I'm going to put plus next to it. F2 D2, that one is going clockwise, so I'm going to put a negative on it. F3 D3 is going counterclockwise. I'm going to put a plus next to that one. And that's how you find the summation of or resultant moment about a force. And last thing that I want to mention, in problems that are 2D and we want to find moment of a force about a point, sometimes it's a little bit difficult to find this distance d with a line of action of the force. So for example, in any of these problems that you see, a geometry like this, it is kind of hard to find that d. Instead, we have like x and y, 2 meters, 3 meters. Or in the other figure, we might have the x and y, the distances. So in a lot of problems, almost all of the problems, it's much easier to resolve the force in the components in x and y, and therefore use the principle that we just learned in this slide, meaning, of course, moment about point O is going to be FD, perpendicular distance. That's the magnitude of it. But sometimes it's much easier to say moment of force about point O is Fx multiplied by distance between point O and line of action of F. This is line of action of F, and the distance between O and that line is this y. And then Fy, distance between O and line of action of Fy. Let me use a different color. This is line of action of Fy, and this distance right here is x. So now let's see. Fy is trying to create a rotation which is counterclockwise. Fy is trying to rotate this way. So it's a counterclockwise, that's a plus. Fx, on the other hand, is trying to rotate this way, which is clockwise. So I'm going to put a negative or a minus next to it. So in a lot of examples, it's much easier to resolve the force into its component and then just add them up together. In the next video, I will go over multiple examples very similar to the one that you kind of see here, and we're going to get a lot of practice on moment of a force about a point in a scalar notation. Thank you.